mass will get half the speed. And so now you're going to see that one car will go twice as slow as the other. That's the only way that nature can conserve momentum. Nature has no choice. Nature can deal with kinetic energy one way or another, but it cannot finagle momentum. So it must give the more massive car half the speed than it gives the other car. And so we're
Alright, it's time for another draftphysics.com, debatephysics.com also. But again, the debate sucks. Unfortunately, this doesn't, they just keep saying things. I just got a comment on the website where a guy says, the Ian Gosling guy says, yeah, it takes 4 times as much fuel to go twice as fast. There's no evidence of it, right? He can't produce any evidence, and he just asserts it, and he says, oh yeah, that's going to convince me, because you say so. No good reason to believe any of that crap. And again, they've had 300 years to produce this evidence, to show us these experiments that we'll never see. And they're not that complicated. Apparently they're complicated enough to fool people like the Brozo. So that's, in some mating videos, I guess I could go back to the gravity video I did. I'm sort of, I could have done that video better, so I hope to in the future make another gravity video. Another one. I mean, the idea is very simple, The Earth isn't in equilibrium. All material objects are not in equilibrium with the universe in the sense that they actually are constantly maintaining their heat. And to maintain their heat, they have to constantly consume a little bit of the energy of the universe. And that ends up being the differential that pulls things together. But anyway, simple explanation. Works, blah, blah, blah. Doesn't matter. Okay. So, so other than that, the rest of the videos have been sort of on the subject of momentum versus kinetic energy, as has dominated for the last couple of years. And their counter-argument is still in the same form of just crap. I mean, let's do an experiment I didn't detail in some bizarre way and then say the experiment proves something when it's not done in any kind of reasonable way. So, because some people can't handle explanation videos that go longer than 5 minutes, I'll try to do a real brief summation of Brozo's mistake. And there's always a mistake. I mean, there's always a way he screws it up because he's always trying to fake it. He only shows us the experiments that come out the way he wants. You can see stuff in the background here, very nice pendulums and stuff. We never saw any videos of that because, it didn't show what he wanted to show. So that's all it comes down to. So he'll force an experiment to some extreme to force it not to work. And then he'll claim it's the real experiment, but it's not really the real experiment because he's forced it not to work. He's engineered it to be in some way or other broken and therefore not producing the predicted results. Okay. Then it's just that it's all kind of obvious. But anyway, you don't have to believe me. Just pay attention to what he does. Okay. So, there's a balance that is really, people call it a lever. It's not really a lever, right? It's made of levers, but it's a balance. Okay, and the idea is this balance allows you to take different masses, and if you put them in different locations, you'll always get a predictable result. Now, their science agrees with this basic notion, that if you go twice this distance, so you could say 2d, call it distances, or a length, an L, would be equal to, a mass increase, 2 mass, 2 times the mass, well, it doesn't really matter. Yes, you could write up an equation that would define this idea that I can move stuff around. So I could have a 2 mass here. I should have made these bigger. And they would balance. And then I can take a 1 mass and put it 2 distances and it would balance. And then I could take a 3 mass, 3 distances, I mean a 1/3 mass, 3 distances, and it would balance. You know, I can do this thing. There's rules. So he takes this lever idea, right, and he calls something that isn't what it is. He calls it a trebuchet, right, and he just does this, okay, this one side of the lever, and he has a spring on it, okay, and he claims this is going to have the same rules as this. So it doesn't look anything like a balance, and he's going to claim it's the same rules. And then, you know, the obvious things that's missing to be a trebuchet, trebuchets are dependent on, the idea is yes, this arm is shorter, but you put a massive weight here, you know, real big mass. All right, and that swings down and that swings up, and so that's how it works. So it's balanced in the sense that you definitely have more weight on one side than the other side, guaranteeing that you've eliminated the meaning of this piece of extra material. So if this mass is 100 times or 400 times as heavy as this arm, then it just becomes sort of irrelevant, the weight of the arm. But because he doesn't have a counterbalance, so his trebuchet is missing the counterbalance, and on top of that he has this spring loaded as weakly as possible, so the arm moves really, really slowly. And so the spring is taking the place of what is usually a 400-pound mass in the case of a trebuchet, you know, a very heavy mass. And he has the spring loaded to like 1 pound or something. And so he's got 1 pound weights, you could say, on the thrower, and he's got barely a pound or 2 of spring tension. And so obviously these rules, okay, where you just go twice the distance to get twice the you go twice the distance, and it allows us a half mass to have the same weight. Okay, so that's the simple principle. And again, I'm playing the Professor Lewin video about conservation of momentum because, yeah, you have to do that in a lever. Okay, so if you have a certain amount of motion here, okay, mass and velocity, okay, you have a certain amount of mass and velocity on one side, you have to have the same mass and velocity on the other side, okay? The masses and the velocities have to equal. You can have big mass, little velocity, and big velocity and little mass, but you have to have the same total amount come out of the other side. And Brozo keeps saying that this comes off with only 1.4, okay, it's half the mass, and only comes off with 1.4 the velocity, breaking this rule, this conservation law. Okay, so the conservation law that you got to conserve the momentum, that's you can't destroy the momentum, you have to account for it anyway. If you're going to say that 0.6 of the momentum was lost, you have to explain where it was lost. You have to show us where it went. And then you do the reverse experiment. You can't sit there and say, oh, when I do the experiment this way, I put the force in here, I lose a big giant chunk of the momentum, but when I do it this way, I don't lose any of the momentum. You can't have it both ways. I mean, it's an obvious hypocrisy. So anyway, so that's, you know, obvious flaws in the experiment he's doing, in the sense that you have no good reason to believe a balance is the same as an imbalance. Okay, obviously a trebuchet is a completely unbalanced lever, and it really isn't applicable to the same rules. You're not going to get the same rules. Now, I used the example of gears, okay, originally, and then, you know, just for expedience, I made the mistake of taking a little shortcut and saying, well, look, the only part of the experiment we need to pay attention to is this part, because we're just going to put a mass on this gear and we're going to put a mass on this gear. And clearly that ratio works. Okay, say this has half the circumference. That means this will have twice the velocity. So the same movement in the gears, this gear will have a velocity that is 1/2 of this velocity. And that rule works. But it's not going to work when you're using some other force, but, you know, some massive torque to make the experiment work. So if you're using very low torque and you don't have the two gears tied to each other, they're not going to move the same, okay, because the amount of weight of the object itself is going to get in the way. See, the balance destroys the meaning of the lever itself, because there's the same amount of it on one side as there is on the other side. Obviously that's not true in this other case. So anyway, I mean, it's physics. It's, you know, there are always things you have to be aware of, little variables, and you know, it's apparent, it's kind of obvious that there's this whole group of nutters out there who just couldn't care less, and they're just defenders of the Bible, and that's all it is. They're just fanatic, like, you know, Muslim Allah loving crazies. They really don't care, you know, that the story doesn't make any sense and that it's not, you know, verified by any evidence. They're just believers. You know, crazy believers. Alright, so I'll play a little of this since it's up here and such. So this was my attempt. So it's a video where first I react to the comments in defense of the same nonsense, you know, where they just keep saying they don't have to convert, you know, to conserve momentum, and you know, that somehow it takes, you know, this whole rule that it takes 4 times the energy to create twice the velocity. And again, I keep trying to point out it's just a deception based on the fact that gravity has this, you know, subtle strangeness, and it's only a subtle strangeness, where you have to go 4 times higher to double your velocity. But it can be understood that, yeah, I'm doubling my velocity, which means I'm moving through the gravity quicker, which means I'm in the gravity less time. They really can't understand that it's about how long you apply a force that will decide how much force affects you. You know, how long you're in the wind matters. They can't really understand that concept. Right, so I have to turn this on and play a little bit of this. Oh, wrong video, I think. I have to click on this one. Alright. Alright, time to here. 2 mass here on a lever. And these things will weigh the same. Okay, so I mean, it's an critical, important point. I mean, here you have 2 masses that are completely different, and they'll weigh the same. That is, they'll create the same pressure through gravity. Gravity will create the same pressure on the lever, you know, because of the distance, because of the fact that you've placed one a further distance from the converting fulcrum, the thing that's balancing, you know, that's measuring it. And again, you could take this lever argument all the way to the extreme. If we could make an ideal lever, okay, so I mean, I pointed out somebody 2,000 years ago, or 4,000 years, whatever it was, said, you know, give me a lever long enough and I'll move the world. Because, you know, they're basically understanding that, wow, this is a great conversion tool. And that's what it is. It allows you to convert the fast motion of a light thing into the slow motion of a heavy thing, okay, and where you can't do those conversions, you know, easily, like a Newton's cradle can't do the conversions. I put little, you know, 1 ounce or 10 gram balls, and I have, you know, 100 gram balls, and I can combine them in a Newton's cradle or something. It won't consistently oscillate. But if I can have something that does the conversion, then they could theoretically, you know, pass their energy on. Something going twice as fast that's half as light could perfectly oscillate with something that's going, you know, that has twice the mass and is going half as fast. I mean, you know. So, I mean, yes, you take the lever extreme far enough, you could do the bullet and the gun. You could have the recoil of the gun on one side of the lever and the bullet on the other side of the lever, and it'll show you that they have the same energy, the same momentum. And it's just, you're just making big V's and little M's, and big M's and little V's. You have 1,000 times more atoms going 1,000 times slower. Same difference. Whether you have the money in pennies or dollar bills or $5 bills or $10 bills, it's the same amount of money. Oh You really have to go all the way back to like ABC blocks with these people. Fast, it can release slow, it can compress fast, or it can compress slow. Okay, so like the compression argument sounds a little bit like the pressure argument, which I don't think was in this particular video. But anyway, but that's the whole point is how you apply the force. And so force is, like I tried to explain with gravity and friction, that, you know, it's really just about the contact with the ground. And the heavier you are, the more contact you have with the ground, the more capable you are of getting rid of your energy faster. And the less contact you have with the ground, the less energy you get rid of. Because it is your energy and you're losing it to the friction. The friction is taking the money out of your pockets, essentially. Of doubling of weight. So the longer it falls... Alright, so this was a commenter talking about the Veritasium video and why does it matter, you know, why doesn't a heavy thing penetrate as much as a moving thing? And again, it's about contact. Why does the bullet look so much dramatically like so much more energy than the 2-liter bottle, you know, traveling, you know, 5 miles an hour? It looks like it, okay, because the fact that it's, you know, the contact point is small, and the fact that the energy is in the form of velocity means that the bullet is going to have more contact with the surface because it's going to penetrate it and it's going to hit a lot more atoms in the same amount of time. So it's going to be able to distribute its energy much more quickly. And the fact that it has a higher velocity means when it does get rid of its velocity, it's going to get rid of it in bigger chunks because it can give higher velocity to the things it hits. So I've been over that with the bowling ball example. You know, the bigger, heavier, slower bowling ball has to give a slow velocity to the pins. So it has to hit more pins to get rid of its energy because it's only giving 10 miles an hour, let's say, to each pin it hits, because it's only going 10 miles an hour. But the bowling ball going 20 miles an hour obviously can give away, okay, energy to the pins in bigger chunks because it can give the pin that has a standard amount of weight a faster velocity, twice the velocity. So in the same pin contact, the 8-pound ball gives away, say, 20% of its energy, where the heavier bowling ball only gives away 10% of its velocity, 10% of its energy. So it's all about how you're distributing your energy into something, how you're connected to it. So I've compared that to, you know, you try to make it so these morons can understand, you know, these people are supposed to know something about electricity. And you can understand that, yes, the more contact your wires make, the more wattage can go through the wires. And the least contact, the less wattage you can get through the wires. I mean, these are things you can understand. You know, and it's the same thing with this thing called your momentum or your energy. If you're going to convey it to something else, you need to make contact with the something else. You need to contact its atoms, its electrons, and you need to give them the momentum you have. Not hard to understand. The better the contact, the more energy distributed more quickly. The wrong weight. It's not a balance. You broke the balance by not having this part of the lever to balance. Okay, right. So it's obviously not a balance unless you put a counterweight on it. So his trebuchet needed a counterweight. If he put a counterweight, okay, that balanced the weight that he has on the whatever you want to call it, the trebuchet, then it would work out where if you moved it, okay, 1 unit of distance, you could use half the mass at that same location, and you would impart upon it the same momentum. But he didn't do that. Okay, so he didn't, you know, he broke the mechanism and then claims it's the same rules. It's not the same rules when it's a different vehicle. A 3-wheeler is different than a 4-wheeler. You know, reasonable people can understand that. There's different rules about what you can do and how it's going to affect your center of gravity and all kinds of things. This video now, he just plays the same clips over Yeah, so he says I'm boring and repetitious and time-wasting twit, and yet he plays the same shit over and over and over again, like he's making some sort of point, like the audience needs him to put it in bold type and emphasize it over and over again. So he's just insulting the intelligence of anybody watching his videos, because they're smarter than he is. And they don't need the emphasis. They get the point. Yeah, okay. Too stupid. It's just so, you're just saying, okay, so you're going to be boring, repetitive, and time-wasting in your effort to fight time-wasting. I mean, it makes absolutely no sense, right? I'm going to cure people with a disease. Yeah, great idea. No, you're an idiot. 18 to 11 ratio, the 20 to 10 ratio. Alright, well, anyway, so we could just play the Professor Lewin clip again and again and just point out how, look, all the physicists know you have to conserve the momentum. If something changes, the momentum changes, you have to account for where it went. You can't just say it disappeared. It's not an answer. It's not a reasonable answer. Alright, so the next couple of videos I tried to isolate some of these different physics arguments I'm making in smaller chunks. Again, I've done that before, but we'll keep working at it and try to put them in a form where people can rationally respond to the actual subjects and the actual points being made, because they won't do that. They just won't stay on the subject. They'll just keep saying things like F equals MA or some other horse shit that doesn't mean anything and pretend that's an argument when it's not an argument. It doesn't deal with the actual subject. It doesn't point out how, again, how can you conserve, you have to conserve momentum, and how do you do that and explain how a lever works? Because you really can't. It's impossible. Levers prove you can't conserve kinetic energy. Okay, it's not possible because it doesn't exist anyway. It's just nonsense. Alright, so this is where I have added
We'll get half the
Lewin clip. Didn't mean anything. And it was clearly dissectable that, well, the reason why they didn't come out exactly the same numbers is because you don't have the weights. Okay, so again, the commenters are all defending nonsense, crappy experiments. And you say, why? Why would they do that? I mean, why would they come rushing always to the defense of poorly done, poorly reasoned, illogically reasoned experiments? And it's just because they're fanatics. They don't care about the truth. It's kind of obvious. All right. The reason why he didn't win the argument was there was no evidence of perpetual motion in Newtonian physics. Okay, so the whole point that I keep raising the history, that they won't address any aspect of the history. So they won't concede it's a bad history. Just as they won't concede the Eddington experiment wasn't a very sensible experiment to base an entire proof on and to say it proved anything, because it was strangled logically for you to think it was a very credible result. I mean, the guy's own journal, he admits it's not a good result. He admits the experiment is really poor data. Supposed to get 10,000 stars in his picture, he got 1,000. I mean, he got 10% of the data he was looking for, hoping for. And it was already a hard experiment. And you can't concede. Oh yeah, we shouldn't arrogantly walk around telling people what the truth is based on an experiment that bad. And these people are just so dishonest. And so the history of the kinetic energy theory is just so bad. I mean, it was invented by Leibniz at the peak of Newton's fame. Newton just predicted all kinds of crap and just pointed out how the whole solar system is a mathematical construct, and predicted things, with incredible accuracy. And there's absolutely no reason. There was nothing broken in the numbers. There was nothing broken in the function. Now, there was the tiny little thing with Mercury, but they didn't even discover that until 100 years later. But anyway, it works really well. Okay, so Galileo, Descartes, and Newton constructed a pretty good model of reality, and this Leibniz guy felt left out, and so he decided to throw in his ball of crap. He made a little ball of crap and threw it on the table. And it was crap. There was no reason for it. It didn't fix anything. It just broke everything. And nobody bought it because the argument clearly was it's a free energy theory. Okay? And we're not going to have free energy. And Leibniz was arguing exactly the opposite. You know, he was saying Newtonian physics was a free energy physics, but he couldn't show any experiment where free energy existed. So, again, yeah. And yet that's what won the day. The nonsense. Just pitiful. Units of time. Alright, so this is the whole reason, is this stupid gravity argument. So that's the first point. And I'm just emphasizing, you know, can't you just see? Okay, it's twice the time, it's twice the velocity. Yeah, it's 4 times the distance. So what? It's twice the other things that are really important, okay? Time and velocity. If it was 4 units and you were getting 1 velocity with 1 unit, why wouldn't you get 4 velocities with 4 units? Can't you see how that didn't happen and that doesn't work? So the 4 units really don't mean anything, okay? Because for 3 of these units, you're going to use the same amount of time as you use for just 1 of them. That's what Galileo pointed out. 1, 3, 5, 7. Well, 1, 3, 7, I think. Well, anyway, it doesn't matter. You know, all odd numbers. 1, 3, 5, 7, 9, blah, blah, blah. That's the ratio. So in the same amount of time, okay, in those units of 7, 5, 3, right, you're going to go a much greater distance, but you're only in the gravity, okay, for the same amount of time. So that's why it only adds up to 2. 1 plus the 3 units, all right, and those are only, the 3 units are going to equal 1 unit of time, because you've got more velocity, obviously. So you're going to be in the gravity less time. I mean, I just don't know why you can't understand how there doesn't make any sense for you to really think, okay, that because gravity does this little bit of a strangeness, that the whole universe does this strangeness. Okay, that the whole universe, and again, it's not even a strangeness when you understand that, obviously, if you're going faster through something, less of it's going to get on you. I mean, you know, that's not even a strange concept. So anyway, so just ignore the 2, the 2 times the velocity, 2 times the time, ignore those, and just focus on, it's 4. No, it's not 4. The 2 and the 2 are important. The 4, not important. So let's call this argument number 2. I mean, how long your rocket engine is on is what's going to give you velocity, okay? Nothing else. Distance is irrelevant. Q, okay, it's just how does a lever function? Okay, so the second point is the lever and the simple rules, okay, and so we're drawing big M, little v, big V, little m, just trying to point out, okay, it's really simple, it's not that complicated, and you have to conserve it. You don't have, there's no latitude not to. And the simple truth is momentum makes perfect sense on a lever, everything works just fine, and as soon as you start squaring these terms and giving things special kinetic energy, everything falls to pieces. It becomes completely irrational. And it becomes a free energy device, which we know it's not because we don't have free energy. How many frickin' times do I have to explain to you? It's already proven. Okay, it's proven by the fact that if free energy was that simple, we'd already have it. It just doesn't exist. You have to steal energy. You can't freely acquire it. I would tell you, I mean, I don't think Professor Lewin can do anything to change this. I mean, Professor Lewin's not going to draw a lever and explain how it works, okay? Because he can't in the context of kinetic energy. Because it makes no sense. It won't work. But in terms of momentum, I'm sure he's explained it. that yes, you have the same, you have a momentum over here, you'll have a momentum over here. Of course, the twice as heavy thing going half the velocity hits one side, the other side with the half mass on it is going to go twice as fast. Momentum's going to be conserved, and kinetic energy is not worth your time because it doesn't mean anything. It doesn't apply. It's not real energy. It's a momentum universe. There's no kinetic energy. It's a lie, a fable, a silliness, a fucktardedness. Yeah, alright, that's all you can do. Shake your head and you say, why are you people so belligerently stupid? Alright, so this video has argument number 3, 4, and 5 in it. And 3 was... I don't remember.
Object is same.
Yes, elastic and inelastic. So I guess I made, there's a slight oversight in the video where, so I'm just pointing out, okay, you can have elastic, is objects that reflect essentially energy. And they can reflect it very fast or they can reflect it very slow, okay, much later. And so that's why a steel ball and a tennis ball can be called elastic and be shoved in the same category, is because one reflects the energy very fast or transmits it through very fast, and the other one takes in the energy, holds it for a little while, and then gives it back. And so I explained the rules of that. And the other thing, opposed to those elastic things, is just something, okay, where you have two categories, something that falls apart, and the idea of something that allows you to take an elastic object like steel or a tennis ball and stick to it. If you stick to it, if you become part of it, that's not really have anything to do with elasticity. That doesn't have anything to do with whether something's elastic or inelastic. The inelastic object is something that falls apart, something where the energy goes in and it's distributed into a bunch of motion of the internal parts. That's truly inelastic. Sticking is a concept that doesn't have anything to do with the realities of nature, so it's not really applicable in any real circumstances. Yeah, even two asteroids, when they meet and they merge, their energy first goes through the process of disturbing the internal parts of the asteroid that's hit. The smaller asteroid, collides into the bigger one, and it moves its internal structure. So it's really not going to be a sticking encounter, because there is going to be a lot of motion in directions not perfectly in the same direction as the object is moving. So the shape of the object is going to matter. Lots of things are going to matter. Well, anyway, see, that's a little subtlety, and it just, it would probably just make the video, 10 minutes longer than it need to be. So probably best not to even get into it. So it'll move with the velocity that's being pushed with, and then it'll do this, Okay, so I'm just pointing out the tennis ball is going to give back its energy in both directions, which is the interesting part. So the steel ball is elastic, but it's, it either transmits the energy or reflects it. And the tennis ball absorbs it, holds it, and then releases it in both directions. So they do behave differently. I mean, there's different rules for the two different kinds of elastic interaction. And that's not pointed out in any other videos, frankly. Alright, so point number 4 is back to levers, but I think this time I'm talking more about the weight and the fact that that's all it's really ever about, is that there's weight on one side of the fulcrum and weight on the other side of the fulcrum. It's just about something moving, a velocity with a mass, and that's weight. And how science doesn't do any of this. It doesn't just drop objects onto a scale and show us how the weight changes. Nobody does that experiment. and it's really critical to understanding what momentum is, because that's all momentum is. When you do mass times velocity, all you're doing is saying how much does it weigh. That's all it is. You have a velocity into the ground right now, and that is what you call your weight of whatever 100 pounds it is. 400, whatever you weigh. And you weigh it because gravity's given you motion. And I can make you weigh 400 pounds by moving you sideways at a certain speed. And that speed will be the same speed that you're essentially moving into the ground. It just tells you weight, pressure. All we can do is cause pressure. One thing can push on another thing. It's a push universe. These are all points I've made over and over. Okay, that it should have if it's rolling, because the roll came out of the energy you use to initiate. So I'm just pointing out how, a lot of these experiments get messed up. So I describe a simple experiment using pendulums and a lever to point out that yes, you can convert a 10-ton train going 5 miles an hour into a 5-ton train going 10 miles an hour. You can do the conversion. And by the kinetic energy formula, that would mean you were making free energy. And obviously, I don't think that's possible. So obviously, the kinetic energy formula is fundamentally inaccurate and flawed. And then I'm just pointing out that, certain ways you can do the experiment. And if you roll things, you have to understand what rolling means. It means that part of the linear velocity is being used to create the rotation. So the linear velocity will be less than what your prediction would be if it didn't roll. And these are real things that people have to consider if they're going to do the experiments. And all you can doing is saying, I'm going to apply the force to a half mass. I'm going to have the same force being applied to a half mass. I have to get twice the velocity. So again, we're back to the Lewin experiment. There's just no point in saying something else. It's the same pressure on all points of the lever. So if I put a 2 mass in a location, I can measure the weight on the other side of the lever at any point, and it's going to be exactly the same reading on the scale. So whatever the rebound is, because of that weight on the other side, it's the same force no matter where I put it. So if I put a 2 mass here, the same force is going to affect it as the force that's going to be affecting the 1 mass. And so the only thing that can change is velocity. So the 2 mass will move with a less velocity than the half mass will move, because I have the same force. It's just whatever. There's 10 pounds on the other side of the lever. There's 10 pounds of pressure. It's 10 pounds here, 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 here. No matter where you go, it's 10 pounds of pressure. 10 pounds applied to a half mass will get you twice the velocity of 10 pounds applied to a 2 mass. I mean, fuck. Not complicated. Alright, this point number 5 is just the pressured vessel argument, which again is just decisive in the sense there's no way around it. You have to conserve the momentum, and you can just see it geometrically, that you got no choice. You have 2 cylinders pushing, okay, on a fluid, and so it's pushing twice as much material in the same amount of time. The 1 cylinder has to move twice as fast. There's no other way around it. It has to displace the same amount of material, and it has to displace it through half the volume. So if I have a half the size pipe and I have to have twice, I have to have the same amount of fluid that went through the pipe that's this big, it's kind of obvious that it has to go through the pipe twice as fast. Duh. And I have to spend 10 years 2 years at making that point. 2 years of argument after argument, and just being, again, nobody makes any kind of rational argument. They all just say, no, 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 I don't want to believe, I don't want to believe. That's it. I mean, it's pathetic. I had no idea this would be the end result of this effort. That you would show people the truth and they would just step on it and spit on it. You go to the trouble to figure out what's broken. You show them the easy fix, and they say, we don't want to hear that. It doesn't have anything to do with the woo we wish to believe in. I mean, it's pathetic. All right. So, I mean, these are darker ages than the real dark ages. I mean, you know, people are yes, okay, there's no Inquisition that's out to kill me, but you don't need one, you know, because the people are the Inquisition. They want it this way. They want to stay stupid. They want to stay living in their fake, phony, bullshit world. Ugh. Tragic. Stupid. Annoying. Alright, so anyway, that's probably enough of a video. And such. So we'll leave it there. There's nothing else to say, really. I did do some comments on the Brozo page, but there's nothing. There's no... They provide zero, okay, counter argument to any of my dissection of what they did wrong. Nothing. And they don't account for any of the facts and how things actually work. They just sit there and applaud and say, great, you broke the experiment, you cheated, you forced a result that really doesn't show the truth. Great job. Yeah. It's just pathetic. Alright, so that'll be it. So we'll go back to Lewin, and I'll get the hell out of here.
You'll get half the speed. And so now you're going to see that one car will go twice as slow as the other. That's the only way that nature can conserve momentum. Nature has no choice. Nature can deal with kinetic energy one way or another, but it cannot finagle momentum. So it must give the more massive car half the speed than it gives the other car. And so we...
Alright, so it has been at draftphysics.com, debatephysics.com also, but again, what's the point? Why bother trying? Blah, 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 blah. Yeah, shit.